Okay, our video today is about audio input and output in Matlab and Simulink both. My name is Colin Konetska, and I'm working here with Brandon Yeager, and I'm going to be starting here about our first file, which is the Matlab portion of it. Okay, so this is our Matlab code portion of that we wrote for this. Basically, we use the audio read function. It's going to load in an MP3 file, whatever the user wants. They can change whatever MP3 file they want to load in. We have our second line here that multiplies fs times the value. So say if we wanted to multiply it, I'll multiply it by 1.5. It just changes the speed of the song. It changes the sampling frequency. So this is going to sample 1.5 times faster, and basically it's just going to play the song 1.5 times faster. So here, if we run this code, it's going to basically, like I said, it's going to play this MP3 file we have right here loaded in. We had an input right here for the user. Get that out of there. We got an input for the user here, so it's 1 to stop the music. So the music's going to keep playing. If they hit the wrong key or anything else that's just wrong value, whatever, it's just going to tell them you didn't enter 1 and then press 1 to stop the music. You know, if they hit the wrong thing accidentally, they're not locked out. So if we just hit the 1 there, you can hear obviously it stopped the music, and then that's what we did there for our Matlab portion of it. Now we'll go over to so we did a couple Simulink files here for this. Okay, as for the next thing we did here in Simulink, we have basically 2 audio files overlaid, and if anybody wanted to, you know, they could add multiple different signs in here if you wanted to change, you know, add them or subtract them from each other, whatever. Basically, you can just send in multiple different audio files at the same time, you know, overlay audio files into Simulink. So we loaded our same song from the last one, then we loaded our MP3 file here. You could also use the gain function to make them louder or quieter, so we quieted down this one a little bit. We multiply it with a gain of 0.1. This one we made a little louder because it was kind of hard to overhear over the other ones, so we multiply it by a gain of 5. We also you can use delays in this, so we delayed this one for a couple seconds here, and then that way it's just going to wait until this song gets partway through and then start this song, and vice versa. You can add multiple, like I said, different ones in here, or delay this one or anything else. So if we run this here, we'll give it a minute here to start running. As you can hear, the first song started playing already. It's a little quiet at the 0.1, and then after a couple seconds here now, there it starts. Actually, the song was full started. It has a little weird audio at the beginning, but that's the second song overlaying over the other one, and it's still a little bit overpowered over the first one. So it's like I said, you know, change the gain or all different things in that. But basically, in here, then you can overlay multiple different audio files for this, and then change how they sound.
Okay, this is Brandon Yeager. I'm picking up where Colin left off. This is our third part of our project. As you can see here, we just made a little Simulink file showing that we have a input audio file. What we did was we used a mono FLAC file for Moonlight Sonata, actually. And the reason we used the FLAC file is because it's better sounding than a MP3 file. And basically, what we're doing is we're sending this down into reshape, because when we tried to actually do this originally, it was giving us a bunch of errors, like saying the size isn't right. So that's why we have the reshape here and the buffer right here, or unbuffer, I apologize. So what this is doing is it's just taking the signal and, get out of here. It's just taking the signal and passing it into a double sideband transmit carrier. It doesn't say transmit carrier, but it is a transmit carrier because Simulink doesn't really post that. But it's passing it into here. It's passing it into. It's adding a additive white Gaussian noise, AWGN for short, and then after that, it's then demodulating the signal and then buffering it out to input it to an audio device. And so I'm going to play it for you guys real quick so you can hear it. Another thing to mention, the spectrum analyzers are what give us these graphs so we can see the song in real time. It's a little quiet, but you should be able to hear it. Okay. Now if you noticed I'm going to stop the program real quick. If you noticed, if I wasn't talking over it, you should be able to notice how it was a little staticky. The reason for that is because of the signal-to-noise ratio. The amount of power from the signal compared to the noise is 30 decibels right now. But if I were to make that 100, the static should appear to go away. It doesn't go away. It just, the power of the signal gets overpowers the noise. So once I do this, you should not hear as much static. Yeah, so just no static at all. That's because of the signal to noise ratio, and that's pretty much it for the AM side. Let me switch over to the FM side. Okay, switching from AM to FM now, we have our FM Simulink file. Same thing, it's in mono, Beethoven, Moonlight Sonata FLAC file, going through the reshape. Now this time, as you can see, it's going to FM, so it's frequency modulated instead of amplitude modulated this time. The parameters in here, I just use the normal parameters you get when you drag and drop the block into Simulink. Additive white Gaussian noise right here is just 30 decibels. We'll get to that in a minute. And I just wanted to notice, or I wanted to point something out to you guys, that if you look here, this doesn't have an input audio device writer, whereas if I pull up the right thing, the AM has an audio device writer. So the nifty thing about that is that FM broadcast actually has it built in right here where it says play audio device. So I'm going to play the audio device really quick. Once again, the spectrum analyzers, they let us see the song going in real time. Let me just play it for you guys. It's taking a little while to load. That's another thing to point out for FM versus AM. AM just loaded instantly, where FM, it's taken a little bit. That's, as you can see in the top middle corner, I changed the time of loading from 239, which is the whole time of the song, to just 30 seconds. So hopefully this loads a little fast. Okay, now that it finally loaded, thanks to the power of editing and magic like that, you can hear the song. And if you notice, it sounds a lot cleaner at 30 than the AM file did. Now, turns out that even if you change this to 100, it's not going to change anything. It doesn't change the static. The static's still not there, which is actually a reason why people use FM over AM, because there's obviously less static. But yeah, other than that, that's pretty much the file. That pretty much concludes the project. If you guys have any questions, just feel free to ask Professor Gray, and I'm sure he'll help you guys out. Yeah, have a good one.